Hey y'all, this is Lauren Malone, and in this video, I'm going to be talking about the empirical rule for normal distributions. Okay, let's get started. So I have an example problem, and I'm going to walk y'all through step by step. Assume that the mean weight of 1-year-old girls in the U.S. normally distributed with a mean of about 9.5 kilograms with a standard deviation of approximately 1.1 grams. Without using a calculator, estimate the percentage of 1-year-old girls in the U.S. that meet the following conditions. Draw a sketch and shade the proper region for each problem. Okay, I think there was supposed to be an is in there, but oh well. Okay, so important things to notice about this problem. It says normally distributed. Okay. It also says a mean of about 9.5 kilograms with a standard deviation of approximately 1.1. Oop, I think that's kilograms. Okay. And then it also says without using a calculator, which is a big hint that we will be using the empirical rule. So I'm going to write that the mean is 9.5 kg and the standard deviation equals 1.1 kg. And the empirical rule. What is the empirical rule? Well, this refers to the 68%, then the 95%, and the 99.7% of the distribution of data, which I will be going over now. Okay, so this is a model with normal distribution. Okay. And basically, let's say this is the mean right here, and there we go, this is the mean. And one standard deviation away from the mean is 68% of the distribution. 2 standard deviations away from the mean, so here's another standard deviation, and another one. So this one, 68%, is 95%. Whoop, that's kind of tiny. And then 3 standard deviations away from the mean, from here to here, would be the 99.7% of the data in the distribution. So how are we going to find the region? So it says, estimate the percentage of 1-year-old girls in the U.S. that meet the following conditions for less than 8.4 kilograms. So how many of the girls weigh less than 8.4 kilograms as a percentage? Well, we're going to need to draw another model. So here's my model for normal distribution. We're going to do N for our mean is 9.5 and our standard deviation is 1.1. Okay, so we're going to write our mean right here, which is 9.5. And I'm going to label this the x-axis as kilograms of 1-year-old girls in U.S. Okay. Less than 8.4 kilograms. Now I'm going to go through this model and write down what each weight is for each standard deviation. So here's the median, the mean, not the median. Here's the mean. 1 standard deviation away, right here, is 68%. So you do 9.5 minus 1.1, and you get 8.4. Looky there, 8.4 is what we're looking for. And then if you add 1, so 9.5 plus 1.1, that's 6, and that's 10.6. So right here, this is 68% because this is 1 standard deviation away from the mean. But that's not our answer because we're looking for this section right here. We're looking for this shaded region right here. So if this was 68%, what we're going to do is we're going to take 100 minus 68, and that is going to give us 32%. But that's not our answer, because this 32% includes this tail, but it also includes this tail right here. And we're only looking for the half that's less than 8.4. So what we would do is we would take this number and divide it by 2 and get 16%. So 16% is our answer right here. And for space, oh, y'all can't see that, sorry. And for space, I'm going to keep using the same model. So between 7.3 kilograms and 11.7 kilograms. So now I'm going to make another standard deviation. So this is 2 standard deviations away now. And I do 8.4 minus 1.1, and I get 7.3. And then I do 8.4 plus 1.1, which is 9. Oh wait, that's not what I was supposed to do. And then I do 10.6 plus 1.1, which is 11.7. And now we're looking for between 7.3 kilograms and 11.7 kilograms. So they're basically asking us what is the second standard deviation, which will be, because these are both 2 standard deviations away, will be 95%. And then I will shade that because it said to. So I'm going to make this darker. I'm going to shade this way actually. Okay. Our next one is more than 12.8 kilograms. So now I'm going to go to the third standard deviation. 11.7 plus 1.1 is 12.8, okay? We're doing more than, so we're actually looking for this tiny tail right here. And since this is the third standard deviation, what we can do is 100 minus 99.7. We get 0.3, but 0.3 includes this tail and this tail over here, okay? And we only want this tail, so we're going to divide by 2, and get 0.15%. All right, and that is how we use the empirical rule without a calculator to figure out the percentages of the following regions for the model. Thank you for watching.